Okay, so we're jumping into intersecting lines, which means when we have two lines and we're looking at when they intersect, we want to find the point where they intersect. So if vector equations of two intersecting lines can be solved simultaneously to find the point where the lines meet. Now this is the key point of this thing here, two intersecting lines. We know these lines intersect. All right, if they didn't intersect, then like two lines in 3D space, in 2D space, unless they're parallel, we'll talk about this in the next section. Let's just go through this. So if two lines intersect, there's going to be a point if we think about the line. So I'm just going to draw these out. Imagine these are the two lines we're looking at with the vector equations above. There's going to be one point here. And when you're looking at this point, you're looking at the x and the y coordinate being the same, which makes sense. So in this space here, if we take the x coordinate of the first line, which is -2, so I'm just going to write here x coordinate, and we're looking at -2 plus 3s, and if this is the same as the x coordinate of the other line, which is 15 minus 4t, so I've put x equals 15 plus -4t there, so that if those things equal, we're going to have the same x coordinate on both lines, and then the y coordinate, not equals, y coordinate, we do the same thing here. So with the y coordinate, we get y, in this top one, y equals 1 plus 2s. And in this bottom function, we get 5 plus t. So now we just rearrange these. We just want to get the variables on the same side so we can make them simultaneous equations. So we're going to add 4t to both sides. So we get 3s plus 4t. I'm going to add 2 to both sides and I get equals 17. And then this other one here, I'm going to take t from both sides. So I get 2s take t. And then I'm going to take 1 from both sides equals 4. So then my simultaneous equation, getting both these together, is going to be 3s plus 4t equals 17. And then we've got 2s minus t equals 4. Now, the method I'm using for solving these is elimination. We could have used substitution, but we have to rearrange for a variable. And this way is just easier. So what we're going to do here is we're going to times this bottom one by 4. So if I times this by 4, I'm just going to put a times 4 out here. Okay, my writing's getting a little bit worse. So we get, this bottom one would be 8s. So 4 times 2 gives us 8s minus 4t equals 16. Okay, and then our top one here is 3s plus 4t equals 17. So now we put these together and we get 3 plus 8s is 11s. Okay, so just put 4t take 4t gives us 0. And then we've got 16 plus 17 gives us 33. So we've now got, therefore, 11s equals 33, s equals 3. Now we're just going to sub this into one of the equations above. So let's just pick this top one. So we've got 3 times 3 plus 4t equals 17. We then get 4t equals 17 minus 9, which equals 8. So 4t equals 8. Therefore, we can divide both sides by 4, and we get t equals 2. Just putting some therefores. Now, we just want to check our answer here. So check, and we would then put in here, we would pick the other equation here. So we're going to pick this 2s one. So we've got 2 times s was 3, minus t was 2. And that should equal, we've got 6 minus 2, and that equals 4. So now we check our equation. That equaled 4. Perfect. We tick. That's a check. Now, the other way we would check these here is we've now got an s value. So if in our graphics calculator we put s equals 3 and t equals 2, these should bring up the same coordinates on both. And you can do them in your graphics calculator quite easy. I will insert a little thing in here for the notes to show that. All right, thanks guys.